Hey folks, so in this video, I'm going to be introducing the concept of recursion. Now a big warning here, you are about to see the worst artwork I have ever produced. I want to get it better, but obviously, this is kind of programmer art. So just kind of bear with me on this next slide, which is going to be absolutely terrifying. All right, so suppose I want to draw a cloud. Let's say I could use PowerPoint's cloud tool, right? So if you go inside PowerPoint, there's all these different icons, right? There's a cloud tool. And I could go and create something, right? And that would actually look like this on the left-hand side. That's okay, but it's like not really cloudy, right? What I want is sort of something that looks like a puffy cloud, right? 3D cloud. And I don't get that from the tool that's there. That's kind of lame, right? Well, I know the whole thing is lame, but bear with me. So maybe though, what I could think about is like, well, maybe if I drew, another cloud inside of it, maybe things would be a little bit better, right? Maybe, it would be cool, right? Is if I had this cloud outline here and I drew a true puffy cloud inside of it, right? Then the whole thing would look like a puffy cloud. So maybe I can try to do something like that. I can try to maybe draw in, another one, which is what I have on the right-hand side here. So I've taken, my cloud basically, I made a brand new one, right? Same, scales, but just a little bit smaller. Fit it in there. Okay, it looks a little bit better. But again, it's like, well, if I could put in a mini puffy cloud there, life would be good, right? Over here, I started with like, well, I need a kind of one over there, and then maybe a little bit, got me a little bit, better because now I had an inner cloud. But I still should do the same thing again. So, I don't know, we could try it. So we can try it. And we can do it again and again and again until I get to a cloud that's so small, it's like, well, I don't really need to put anything inside of it. It's already as small as it's going to get. And this is what I get out of it. I get something that looks a little bit more like a 3D cloud. Again, let's just pretend my artwork is awesome. It doesn't look as horrible as this. We get a more than 3D looking cloud. So this is recursion. Basically, the idea is I've built something from itself. So I wanted to make a 3D looking cloud, right? So what I did is I said, okay, I'm going to do a little bit of work, right? Maybe I draw an outline of a cloud. It's even worse than the clip art. And then I draw another cloud inside of it, right? And I just do it again and again and again. So somehow the observation there, right, is I do something on the outside, right? Do a little bit of work there. And then if I would just do the whole thing, right, make another 3D cloud in the middle, it'll kind of just take over, right? And then all of a sudden it's like, well, I'll do the same thing again, make another cloud in the middle, and that cloud in the middle, and that cloud in the middle. Cool. So yeah, the basic idea of recursion is to solve a problem by solving itself, or by solving a smaller version of it, I should say. Okay, let's try and make this a little bit more concrete. Initially what we have is the idea of a size n problem. So there is basically the whole problem, right? So I'll use these two terms kind of interchangeably. One is size n. The other is whole problem. Right, so this is the whole problem. So what is the whole problem in our example? Our whole problem is to draw the entire cloud, right? So that entire outer region, right? That is what I care about, right? That's the whole problem. That's my entire cloud. Okay, fine. Now, in recursion, what we then say is that our whole problem contains a subproblem. Our subproblem, well, there's now going to be a couple words for it. One is to say it's the n-1 problem. Another word is to say it's the m-size problem. Or to me, I just say it's the subproblem, right? To me, I think that's the easiest thing to say, subproblem. The subproblem is basically the inside cloud. So the one that I've kind of filled in a little bit, I've graded a little bit, this is our subproblem. So this is the thing where it's like, well, say I'm trying to solve the whole problem, I could somehow think about doing a little bit of work, right? A little bit of work maybe is somehow defined as like this stuff here, right? Drawing the outer cloud, and right, doing or solving the subproblem, right? So the full-size problem is basically a bit of work plus solving the subproblem, right? That's how these two things are related. So yeah. So actually I'll also write that. So I'll say whole problem equals subproblem plus work, okay? And in here, right, there's somehow this idea that the subproblem is less than the whole problem, right? It should be less work. All right. So that's one idea, right? So it should be less work. It should be smaller according to some size metric, right? So here I'm using the number n. Somehow, right, n is like maybe the size of a list or the size of an array, right? It's this number of things I need to work on. A key observation here is that my subproblem and my whole problem should be of the same type. So I start with a cloud. I also need to draw a cloud to draw the outside cloud, right? I should do the same thing. I can't always have the flavor of my problem changing. They need to be the same. Okay, they must be the same. Otherwise, things will just break. All right. So yeah, every time basically we go through this, right? What we want to do is basically say that we're doing some work, right? We're doing some work to solve the whole size problem, and then we're doing that what we call a recursive call to solve the subproblem, right? So we're solving something in terms of itself. And that subproblem should always be simpler, right? Simpler, 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 until you get down to what we call a base case. The idea of a base case is it's something that's so simple, so trivial, that you can solve it instantly. You don't need to go and make any other calls to do additional work. You just can solve it immediately. So yeah, that we call that I call the base case. Other people will call it something different. I like to call it the base case to link it to induction, right? So induction, mathematical induction, right, is something you guys learned in your previous discrete math course. This is somehow analogous to that. All right, so that's kind of our overall view, right? Whole problem, subproblem, right? Subproblems get smaller until we get to that base case, which is a trivial thing we can solve instantly.